Hello and welcome to another tutorial session on my YouTube channel. Today we continue with the questions on Northwest Regional Mock 2020 Advanced Level Further Mathematics. Now we are going to be looking at question 2 on that paper, and that question reads, as you can see on your screen, that we should find the general solution of the differential equation x dy dx equals to y plus 6x squared cosine of 2x for 4 marks. The B part of the equation reads that we should express 9x squared plus 18x plus 13 in the form a into what? X plus b all that squared plus c, where a, b and c are all real numbers. Hence, we should use this substitution to evaluate this integral. No. So with this now, that's the question that was given for that year, question number 2. So let's see how this can be solved. We are going to be looking at this differential equation now. This is what has been given to us. We have to recognize that this is a linear differential equation which can be transformed to an exact differential equation using an integrating factor. So the first thing we'll do is we send this y this way. That's, we send y to the left hand side, and we have this relation here. Now next we are going to divide all through by x. It will give us dy dx minus 1 on x y equals to what? 6x cos 2x. That's when you divide both sides all through by x. This one now will become x, no more x squared. Now in the next step, we are going to look for the integrating factor. Once we have it here, before looking for the integrating factor, you have to ensure that the coefficient of dy dx is 1. Then now this coefficient of y here will be what you are going to be integrating in the integrating factor. So the integrating factor of this differential equation is e raised to the power the integral of what? Minus 1 on x. We read it alongside with the sign dx, and when you integrate negative 1 on x, it gives you what? Minus ln x, right? So that's just equals to what? E raised to the power minus ln x. And when you simplify this is a ln of what? This e raised this is the same as e raised to the power the ln of 1, that's x to the power negative 1, which is what? 1 over x. And the ln, you know that this is the inverse property of logarithm, so that will just simplify to 1 over x. Now we're going to take this integrating factor and multiply all through this differential equation that we have here, this one. So when we multiply all through by x, we are going to have 1 on x divided by dx minus 1 on x times 1 on x give minus 1 on x squared y equals to what? When we multiply by 1 on x, it will give us what? 6 cosine of 2x, since the x will just cancel out. The next part of the solution now is for you to recognize that this is what? The derivative of a product. So this is a derivative of this product. Look at it. When 1 on x is kept, y is differentiated, and when you keep y, you differentiate 1 on x. When you differentiate 1 on x, you give what? Negative 1 on x squared. So this is just a derivative of the product 1 on x times y. So this is just equals to this. Now from here we can integrate both sides with respect to x to isolate 1 on x times y. That will give us, that's the same as y over x equals to the integral of the right hand side, that's 6 cosine of 2x dx. And when you integrate this guy, cosine of 2x, because it's just a constant, it can come out. So when you integrate cosine of 2x, you are going to have what? A half sine of 2x, and a half of 6 will give us 3. So that will give us what? Y over x equals to what? 3 sine 2x plus a constant k, the constant of integration. So making y the subject, we have what? 3x sine 2x plus what? K times x. That's multiplying all through by both sides of the equation by x, where k is just a real number. So this is the general solution to that differential equation, 4 marks. Please, if you are new to my channel, kindly hit the subscribe button and don't forget to turn on the notification bell so that when new videos are uploaded on this same channel, you will be the first to be notified. So let's move on to the next part of the question. We have to express this in the form that, so we have this our quadratic that has been given to us. Looking at this form, all they're asking us to do in this equation is just to complete the squares of this quadratic. So this is what we are going to do. We are going to factor out 9, because to apply the method of completing the square, we want to ensure that the coefficient of x is unity. So we factor out the 9. By so doing, we will divide each of these terms now by 9. So we will just left with what? Where it's divided by 9, we left with x squared divided by 9. 18 divided by 9 gives 2x, and you have 13 divided by 9. And now with that, now we can see that to complete a square here, we look at the coefficient of what? X. We take half of it. Half of 2 is 1. You square it. When you square 1, you have 1. Add and subtract it. So we are actually adding 0. So it does not change the expression. So I add 1 and subtract 1. I copy the other terms. Now this first part here is just a standard perfect. This is a perfect square that everyone can easily recognize. This is just what? X plus 1, all that squared. So when we copy that and replace, you simplify this guy. Negative 1 plus 13 over 9 will give 4 over 9. And now we open up the parentheses by multiplying all through by 9. That will give us 9 into this, and when we multiply it by 9, we cancel out, leaving out 4. So we have it now in this form. We can clearly see that the value of a is what? A is 9, b is 1, and c is 4. So those are the values of a, b, and c. Now with that, now let's use, they ask us to use hence. It means that we should continue with the first part of the answer to answer the next question. If the word, remember, this integral can be integrated using several methods, but since I've used the word hence and also to use this substitution, you must use it. If you do another method, you score a 0. Very important to note. But if they use the word otherwise, hence or otherwise, the otherwise there gives you liberty to use your own method. But once you see the word hence, use the method that has been asked in the question. Use this substitution. So I'll just go ahead and write down the substitution. Since a is 9, I'll replace here by 9. The square root of 9 is 3. And then now b is 1. And the square root of 4, since c is 4, is what? 2. 2 sans u. Now from there, now once we integrate this function here, we need an expression for the x, since we are using this substitution. So differentiate both sides, we get 3dx equals to what? 2. When you differentiate hyperbolic sine of u, it will give us hyperbolic cosine of u, or you can call it cos. So this is 2 cos u du. Now from there, now we can see clearly that our integral can now be written as, now let's forget about the limit first and get how to integrate this, because once you have the antiderivative of this, once you have a primitive of this function, sorry, you will have, then it will be easy for us to just substitute the limit and everything follows. Now we have to note that in this this integral here, we see that the denominator is exactly what we started with here. So we just copy it and replace. As you can see, you just copy and replace. Now the next thing now we are going to do is to use the substitution as it has been given to us. This is our substitution. So we are going to replace the 3 into x plus 1 equals to 2 sans u. So we recognize that this 9 can be written as 3 square, and we can bring out the square to have 3 into x plus 1, all that square plus 4. Next, we replace this 3 into x plus 1 by what? 2 sans u. That will give us what we have there. And we know that the x, if we make x the subject here, the x the subject, we have what? 2 on 3 cos u 0, and replace it there for the x. And the denominator, we still have the radical. Yes, now from there we have replaced it by what? 2 cos 2 sans u, all that square plus 4. Now let's simplify a bit. This is what? 2 raised to the power 2 give us 4. This one can just come out of the integral because it's just a constant. We are going to have 2/3 integral of this, and when you do this, this is 4 sans u, all that square. We can now bring out the 4. That will give us what? 4 into that, right? I'll factor out the 4 completely. Now from using hyperbolic identity, we know that sin squared cos squared u minus sin squared u is equals to what? 1. So it means from that relation that sin squared u plus 1 will be what? Cos squared, right? So we're going to replace that that one now by cos squared. And when you take the square root of this, the 2 will just give us that, and the half, the square will just disappear. And now the 2 can simply cancel. You can see very well, 2 here, 1, 2 here, 1. You are left with what? 1/3 integral of what? Du, because the cos cancels out, and when you integrate du, you just have u. So that's just u over 3. That's the integral. Now with this information now in mind, we have to go back to our substitution. We know that our substitution was what? 3 into x plus 1 equals to what? 2 sans u. And from there now we are going to make u the subject. If you make u the subject, divide both sides by 2, and then I take sin inverse on both sides. I will give us u directly. That's our u. Now we're going to, since this u, then our integral that we started with the limits now involved, will now be equal to 1/3 sin u, because our u is what? Sin inverse of 3 on 2 x plus 1. That's our u, and 1/3 is just the fractional part of the answer. Now put our limits, and then now substitute the limit and simplify. When you put 1 here, it will give us 2. The 2 will cancel out with this 1, giving us what? 3 left. So that's sin inverse of 3. When you put 0 here, you'll be left with what? 3 on 2. That's just what? Sin inverse of 3 on 2. And we know this identity, inverse hyperbolic sine, that's sin inverse is equals to of x is equals to the ln of x plus the square root of x squared plus 1. So we're going to just replace using that, and that identity is true for all values of x in the set of real numbers. So replacing that using the formula, we just have that. So sin inverse of 3 will just be the ln of 3 plus the square root of what? 3 squared plus 1. Similar thing here. the Sanch inverse of 1.5, that's 3 on 2, will be what? 3 on 2 plus that's a ln of 3 on 2 plus the square root of what? 3 on 2 square plus 1. It's just a standard identity for inverse hyperbolic function of sine. Now, simplifying that using a bit, when we simplify this one will just give 9 plus 1, 10, and this one gives what? 3 square is 9 over 4 plus 1. So when you add the two fractions, you get what? 13 over 4, and the square root of 13 is also 13. Square root of 4 is 2. You have this. Now if you combine these two logarithms, you end up having this as an answer: 1/3 ln of what? 2, because this is subtraction, so we have to divide the logarithms, and the 2 here is a common denominator. It will just swap up and you have the other part as shown. So that's the final answer of our integral. I thank you all for watching. See you guys in my next tutorial. Bye bye. Stay tuned. I love you all.